So we'll get started again. I'm a little behind my pace, so I'm on a few slides I may be rather quick, because there's things we want to do at the end as well. So I have talked about, I've used the phrase room in the humus when I talk about a big leaf plant with a more condensed root system, big roots, but packed in rather than like a big mass. Let's talk about what's going on there in the root zone from another perspective, and that is the perspective that all roots respire carbon dioxide. And in a meadow-like ecosystem, the tap-rooted scenario I've been talking about, and this is a picture for the book, so things look really close to the trunk, so we could fit it in one drawing. I don't have plants growing right up tight against the trunk like that. In that tap-rooted meadow ecosystem, the fruit tree roots are going to intertwine between the roots of the tap roots and whatever grasses and clovers are there, and there is no overconcentration of root density to cause apple roots to want to go somewhere else. So when I talked about biological mowing, which we're about to examine a little bit more, I said the statement, I cut back the other plants to shock them for that spring feeder root flush to take up nutrients. In that system, everything is working fine. On the other side of the tree, nearest to me, that's a setting where the grass is mown regularly, every 7 to 10 days, whatever it takes, to maintain and build a lawn. And part of the idea of mowing is you decrease plant diversity, so it's just grass, and you are making a denser sod for that lawn look. And with that, you're also essentially training the root system of that sod to become more dense within its cubic foot volume space. And in fact, it's about 20 times more dense than that meadow ecosystem on the other side. And 20 times more dense means much higher levels of carbon dioxide. And what happens as a result is the feeder roots, rather than going into those top several inches where so much nutritional action takes place, dive deeper down. Deeper down means that they're going to take up more nutrients as soluble ions rather than partially built nutrition. And that in turn is going to take more energy. And so those trees, they certainly are green, they certainly grow shoots, they grow fruit, but they don't have the same innate resistance to disease. They don't have all the advantages going full bore. And it's all based on that choice of, like, I want to see trees in a golf course fairway. You know, if you're adamant about that, I'll never be able to talk you out of it, and that's okay. You know, so I say sometimes, yeah, this is why we're behind. Sometimes I do consultations, and I'm thinking of this one scenario, and the wife, the woman totally gets me about the biological connections and the fungi, but her husband just really wants that golf course fairway look. And she called a year or two ago about, we're having such a drought, and my trees are really suffering. And I said, yeah, you can water, but remember we were talking about the mycorrhizal network delivering water, how important fungal foods are. And it's like I became like a Mary parent, so it's no longer like just about orchard. Next week we're having our meeting in the Berkshire Mountains. This will be the 28th year I've got together with growers like my friend Hugh. And 20 or so years ago when Hugh talked about mowing, he's a biogenetic grower. It's a technique to ripen mineral humus to the benefit of an extreme diversity of fungi. You know, ever since I considered it my job to translate Hugh to the rest of the world, because he's spot on about it. It's like mowing is not cutting the grass so it looks like a lawn. It's like there's so many things going on here. So we have the ability to pulse nutrients into the mycorrhizal feeder root system, as I was saying, in the immediate weeks after blooming, when I start doing this. I use a side. I do that for two reasons. I like to quiet on a piece of a side. It's also good for me to have workouts. You know, I don't go to town to go to club fitness or what have you. But the other part is I have ground and rocks are in there, and I can choose. I don't want to leave the country in bloom, but I want to mow down this swath. And I basically go around the tree and swath underneath chopping all the plants I cut, just as feeder roots are taking up nutrients. The plants that I'm cutting are essentially just going to seed, and it's in that green seed stage that farmers traditionally cut hay because they have maximum nutrients. Well, it's at that stage, think of the oat plant here, the wheat plant. You plant it, green, comes up with green, vibrant, high in nitrogen. It stalks up, starts to set seed. A little bit of gold goes into the stalk, it's getting a little more carbon. And by the time the seed is mature, it is now this carbon-rich straw. And so that's grading again. Right at the time I'm cutting, I'm laying down a mulch that has a carbon and nitrogen ratio of basically 40 to 1. Fungal sweet spot. And because I deliberately leave a ring mulch, that further suppresses the recovery of plants I just cut, which again helps with nutrient availability. You know, if the larger scale orchard, you don't have a size, it might be a sickle bar, but the idea being that a mulch type mowing is ideal at this time. That's what I want to establish. I go on in the summer months to keep access lines. So I might mow every other row, and the reason for that is that 2 week stagger means different things within the leaves, conscious, all these factors. And the fall mowing is where I seriously pretty much everything, except maybe certain plant stubble that I do for beneficial insects. Because I really want to chop up leaves, they decompose, and I really want to reduce bulk covers so they can't high hawks and whatever is out there to get those little mammals. Another group of plants that you could have in your orchard are nitrogen fixers. So remember what I talked about when I was driving orchards and spacing. You know, this is some planting and not all plantings. Or you might do something like this towards the end of the row. Nitrogen fixers. Some people plant an almond tree and then a stone tree and then nitrogen and then repeat that pattern. And I would like to make their own exactly beneficial. I have more rows, sometimes they're herb, and I have pocket places where I feel I fit in that. But here, the idea is that things like Siberian pea shrub, berry, fix nitrogen on the roots, and nitrogen bacteria, and those plants in the orchard ecosystem can be managed by compacting so that the growth doesn't overwhelmingly devour fruit trees that you're trying to grow. So at its simplest, this idea I chop and drop is laying that cut plant down. This is not a great picture because I wanted to show you that picture. This is comfy that's not that mulch I utilized before. Nor did I throw all the mulch up against the trunk. I want it further out from the duff zone. What I like to do with these plants is manage the dramatic accomplishment. But these are plants that come back from their root system. Less dramatic accomplishment like cutting into the stems that are 3 years old and one stem, or 3 and 4 years old and one depends on the growth. But that root system continues, so it's fixing nitrogen. But those stems are now an indoor source of raw wood, whether I choose to run a chipper or I do that in Clover buried piles of brush. So now we're starting to tie these ideas together. Now this is really cool. So I described briefly ectomycorrhizae as of the forest trees and endo-affiliated 85% of all the other plants. And that ectotypes have 12 runner hyphae. Well, in between the groups, there are what are known as those soft hardwoods. So now I'm talking about things like alder and willow and popple, soft maple, pawpaw might be in this, filbert might be in this. It's not totally defined. What we know about the realm is what we're basically about. But these soft hardwoods act as a meeting ground fungal systems in the sap of that plant being able to pass nutrients along to the other fungal system. And so the ones 12-foot runners can reach down into bedrock and literally drill minerals from bedrock, deliver it to the soft hardwood, which goes out into the endo pipelines, all the other plants that make up the ecosystem. That becomes like a new level of fertility from within the orchard itself. And when I say this, I'm not necessarily talking that such trees have to be right next to the fruit growing. I mean in the orchard ecosystem. Over here I have my apple trees, and there's a lower part of the farm, and willows are growing vigorously there, swamp alders. Well, they're connected to the grasses, clover, flowering herbs. So the nutrients are moving through the ecosystem. It's not like you have many neighbors. And plus on top of that, roots reach your waves. Clovers are certainly nitrogen fixer. One thing to know there is that the red clovers have a much stronger mycorrhizal affinity than yellow and white clovers. I'm not saying yellow and white clovers shouldn't be there as well. Definitely some of the red clovers really enhance that mycorrhizal networking. Another cool thing about red clover is only bumblebees and long-enough tongues access the red clover. So again, it's a good bumblebee plant. And many plants can be seen kind of lupins, nitrogen. They're important for different butterfly species. Again, it's just all about this cascade of diversity. This picture isn't that diverse, but it's pretty pretty. This is a pecan orchard. Now, the pecan orchard has managed to have the ground a little bit bare at the harvest time, because it likes the nuts up around the ground. But here's a summer cover crop of crimson clover. And again, it's pulsing in the diversity. It's not there permanently. It's an annual crop. Another grouping of plants are what are known as beneficial accumulators. So now we're talking about small flowering plants, not small plants, but plants with small flowers that serve as nectaries for adult beneficial insects. So this can be things like buckwheat, which really Pacific fly loves, and we're going to see what a Pacific fly larva looks like in a minute. Anything in the Umbelliferous family is in this category. Sweet Sicily, if you've ever grown this herb, has anyone grown sweet Sicily? Do you know sweet Sicily? The seed pod tastes like licorice. It's like you get this planted candy in the orchard that you get to eat for like a week when it's really nice. But it's attracting all these great insects. If you are growing rhubarb somewhere in the ecosystem, let some stalks go to flower. And you'll see a whole universe of beneficial insects come and be attracted to that. Plants like angelica. Again, the beat just goes on and on. You can incorporate diversity in lots of ways. It's not like it's everywhere. Plant in clumps. Think about succession and bloom, so that the different pollinators are finding nectar as well as the beneficial insects. Grasses belong in there as well. Not necessarily. We don't want the rhizome types, the Johnson grass and the crackgrass, at least not near the trees, because that's problematic in keeping that ground open. But basically, you're just steering things towards that orchard edge. What do you find on the edge of the orchard? The more you create diversity, the more you're going to see out there happening in terms of wonders like this. This is that civet fly larva. The civet fly is a golden fly. It has two wings. It's about the size of a honeybee, but it's definitely a fly, and it hovers, and its larvae eat like 40 aphids a day. Why is that happening? Because you have buckwheat and hardy marguerites and different flowering plants that do civet fly adults, who then sense when aphids are present and they lay their egg. Within a few days it hatches, and the dragon is doing its duty. As you go about observing your trees, you're going to see many things. I used to find these different, and I still do, groups of insect eggs. So my first impulse was, well, I better smush this. This is insects. This is probably trouble. But that was, I knew better. And letting things hatch unless I knew it was a specific problem. And there's very few that I know are a specific problem. Like in the spring, when you're pruning, I'm guessing here in their ecosystem having this in it. And there's a pencil diameter shoot, and at the base, somewhere along it, you see like several concentric rings of eggs. Has anyone ever seen that? That's the tent caterpillar. So I always break that little wedding band off because I know what tent caterpillars do. Do not have tent caterpillars in Indiana? And again, I'm here, once I mention it, you're going to get it. So tuning in that way. But these eggs, in this case, become these little alligators. They're the ladybug larvae. They eat tons of aphids. I have this one pair has a real problematic issue with these black aphids. Not pear, plum. And it doesn't go for my other plums, but it just goes for this one stand every year. And I try to knock it back a little in the beginning, but I know that the ladybugs come on strong. And so we manage and I get a crop. There are all sorts of wasps, Draconiid wasps, Accumulators wasps. This is a parasitizing a gypsy moth caterpillar. Many of these you'll never identify. You won't know what's going on. But what you will know is, as you have all this diversity, your pest pressure is a lot less than it would be, but you won't know that because you have all this diversity. So what do insect allies need? They need that adult food, that nectary. They need, sometimes, to build up their numbers, alternative hosts, and I'm going to explain that in detail. They're not just there for what you consider an orchard pest at the height of summer. They might be there in the spring, through the summer, into the fall, plus then need to overwinter. There's ways to enhance that ability to prey. And they also need shelter, particularly through the winter. So here's one of the versions of what that looks like. This Draconiid wasp, Macrocentrus, is a parasite of the oriental fruit moth. So when we get into the insects, one of the big, I'm going to distinguish between moths that are surface feeding caterpillars and moths that are internal feeding, go into the fruit to feed. So the primary internal feeder is codling moth. Codling moth has a cousin called oriental fruit moth. If you're in an area where peaches can grow, you're going to have the two of them. Where I am, peaches don't overwinter very well, and I have a cousin called the lesser applewworm. But right now I'm focusing on oriental fruit moth. Now we're going to see how oriental fruit moth, when it stings a plum or a peach, some gummosis comes out of that wound, and that becomes an opening where brown rot can get in. So not only does the moth, potentially the larva, eat the seed cavity and the fruit falls off before it even ripens, but those that stay on the tree may be subject to more pressure. And so it becomes relevant. On the other hand, if you know a few things about the cycle of Macrocentrus, a good 85% of this particular pest can be taken care of. An oriental fruit moth not only goes for peaches, but the next generation goes after apple fruit, and it eats around the calyx end, and that's where you'll visually see the little worm at harvest time. The way this works is like this. If in your orchard ecosystem you're growing strawberries, I don't care if they're wild strawberries or garden strawberries, you're very likely, even though you won't be aware of it, to have strawberry moth, strawberry leaf roller. And a moth that's called a leaf roller is the larva actually rolls the edge of the leaf around itself to protect it while it feeds before it pupates. Strawberry leaf roller is the spring source of food for the Macrocentrus Draconiid wasp. Then it goes into the cycle of oriental fruit moth, first on the stone fruits, then on the apples. Then, if in the orchard ecosystem you're growing sunflowers, the sunflower moth will be a pest that you won't be aware of, and that larva becomes a food source for yet another generation of Macrocentrus to carry it closer to winter. And then, if you're able to overcome any vestiges of having German heritage, and you feel compelled to totally clean everything up in the yard, and you let the sunflower stalks stand through the winter, that's where Macrocentrus, and I have German heritage, so I can say that. That's where Macrocentrus will survive and come back the next spring to get strawberry leaf rollers. So there's this, through diversity, this building of those fundamental rules that allow beneficials to increase. You have Japanese beetle in Indiana, correct? So Japanese beetle, having come from Japan, didn't necessarily have the parasites that keep that more in check in Japan follow. Here on North American content, we have something called the Typhia wasp. And the Typhia wasp adults feed on the honeydew of aphids associated with trees like maple, cherry, and elm. Peonies contribute here as well. You'll never see this, but those wasps fly low over the ground and can sense where Japanese beetle grub is 2 to 3 inches down, and they tunnel down in and they insert an egg inside the grub and then leave and go look for another one. And that's the kind of thing where balance comes about. So if Japanese beetle moves in, it's going to take 5-7 years to some of these advantages take place. This one's good. So there you are, you're doing your ramial chipped wood, you're creating a more forest edge ecosystem under the tree. That in turn creates habitat for things like wolf spiders, ground beetles. You'll see these in a grassland environment too, but you're going to see there's going to be more habitat for them. So what's relevant about that? When we talk about certain insect pests, things like plum cuculeo, apple maggot fly, European apple sawfly, well, their larvae eat the seed cavity, destroy the fruit drops to the ground, the fruitlet drops to the ground, and then they crawl out to go into the soil to pupate. When you have more things like these ground spiders, they're going to intercept a greater and greater portion of that traffic, and you're going to see less coming back at you the next year. Again, a lot of this you won't see. Birds certainly contribute, so making bluebird house nests and whatever other habitat you can provide for birds is valuable. Simply growing stone fruit somewhere in the orchard ecosystem, they don't have to be side by side, means that the very first aphids that come are feeding off of the extrafloral nectaries of stone fruit species, prunus species. That becomes a food resource for ladybug beetles early, so their numbers are ramped up and ready to go when green aphid and rosy apple aphid comes onto the apple trees. Again, you won't directly see that, but this is what happens through diversity. If you grow blueberries in the orchard ecosystem where you're growing apples, the apples have a major pest called apple maggot fly. Blueberries, if not sprayed with chemicals, probably to some extent experience the blueberry maggot fly. Both of those pests become a food resource for a berkhanid wasp that keeps each in check. You know, you don't want to wipe out the maggot fly entirely, because then you won't have this pest, and then when the pest, you won't have the good guy, and then when the pest gets blown back in, so there's a balance to this. You know, you can do all sorts of things with weird pipes and little tunnels and holes for spiders and for pollinators, and we're going to talk to the pollinators in a minute. There's a book put out by the Xerxes Society called Farming with Native Beneficial Insects, and I consider this a really important guide. So it details hedgerow plants, meadow plants, structural grasses for about 12 different ecosystems. And it also talks about some of the beneficials, but it also gives you ideas of how do you incorporate that into your ecosystem, how do you get certain plants going. So in the Midwest, some of the wildflowers you probably have on your land, but you probably don't have all of these. And this is what's going to support more insect habitat, more of these beneficials. So the ones that, things like golden Alexander, which is a member of the parsley family, that's quite common on my land. We also have dogbane. What I didn't have, and Virginia mountain mint is on the eastern list as well, was that plant. So I did buy 6 plants from a nursery and started them in locations in the orchard. Now they're seeding, and I'm seeing it coming elsewhere. So you can get these things going, but that book is a really great guide. The structural grasses, not that green carpet, but more clump grasses, they have a great role in terms of just supporting all this different diversity. When you get into talking about pollinators, I've been mentioning bumblebees. They certainly need our help. We all know about honeybees. They need our help in the form of less neonicotinoids being used in the world. But then there are all the solitary bees. Now, some of those bees live in holes like in fence posts or drilled by woodpeckers in trees. Some of them live in patches of open ground, sandy soil. The one known as the blue orchard bee, also called the mason bee. It's an osmia species. Here's how the math works. Typically, it's said that one strong hive of honeybees is needed to pollinate an orchard. So by this, I don't mean like a starter nuke with a new queen being brought in. I mean a hive that overwintered and has 40 to 60,000 worker bees. And it takes that many because a honeybee comes into an apple flower from the side, gets some nectar and leaves. Another honeybee comes in, another honeybee. And it takes on average 6 visits by honeybees to fully pollinate the full seed cavity of the apple. So if you've ever seen an apple grow and it's like flat on one side, if you cut it open, you'll see that seeds didn't develop on that flat seed because the honeybees didn't visit that side of the blossom. But bumblebees and blue orchard bees buzz pollinate. And in that action, they get the job done on one visit. So it takes 200 blue orchard bee females to pollinate an acre of orchard because they're so much more effective than honeybees in how they do it. And they also start at dawn and they work till dusk, where honeybees they keep bankers hours and they don't work if the temperature is up, not above 50. So encouraging that. Here's some notes about different ideas. I showed you that little garden center with all the different holes. I have sections of PVC pipe out in the orchard in which I've inserted cardboard tubes, and the tube diameter needs to be 5/16 of an inch. That's how you get more females than males. And they're really like the key workers in my orchard in terms of pollination. And the bumblebees, if everything's in sequence, are certainly contribute as well. The solitary bees become really important if you're trying to grow apricots and plums and to some extent peaches, to some extent pie cherries, sweet cherries, because those tree fruits bloom earlier than apple and usually it's colder, so the honeybees are definitely not going to be in the picture, and bumblebee brood isn't going to be out and about yet. And usually when those things, you'll see bumblebees, but they'll be the queens, but the brood, the numbers aren't there yet. There's another book put out by the Xerxes Society called Attracting Native Pollinators, and this explains the habitat of all these various little bees and different hints of how you can go about increasing their numbers in your ecosystem. But then I have my friend Marion, grew up in South Africa. Go ahead. Yeah, so they have worksheets, they have handouts. Sometimes they're at different conferences. They're just really good people to connect with. These are just the 2 books that are another way to access this information. But I have a friend, Marion, who grew up in South Africa. And she told me, as I was getting into farming, that a whole nother way of thinking about this, and I like this a lot, is you need to leave some really wild places for the fairies. I mean, that's those wildflowers, that's where these beneficial insects, so that's where these wild pollinators are going to come from. And all of that pushes me in a more wild direction. So now we've covered all the natural advantages that I try to get into place to grow fruit in a healthy way. Now we're going to get into some of the challenges and another way of thinking about how to change that dynamic. And so to address a challenge, whether it's a disease or an insect pest, we have to know where it comes from. We have to know what it is in the case of disease or who it is in the case of insect pests, and not go about it willy-nilly. We don't just put out red sticky ball traps because we saw something was chewing on the apple. The red sticky ball trap may have nothing to do with that. We don't go spray to boost immune function or competitive colonization in late August, because the disease happens at another time in the season. And well, let's get into it and we'll see. So this idea that farmers have to spray fungicides, that disease is going to happen unless we medicate, that's not a very healthy way to think. It applies to us as well as to plants. And if plants did not have their own wily ways through phytochemistry to resist disease, there'd be no plants. The diseases would have won. Again, disease is about everything we've been talking about this morning not being in place, and thus the potential for problems is a lot higher. So for we humans, this notion that from somewhere are these minute organisms that we can't see, germs, is deeply implanted in our psyche. That, you know, germs out there, I mean, it's still implanted in our psyche. This whole thing of antibacterial soaps, you go into the bank and that's a really dumb idea. We're going to get into what's a better idea. Go to the time of World War I and what was called the Spanish flu took place. We had no idea what a virus was. Well, that influenza was caused by something called a virus. You know, the word influenza means of the stars in Italian. It's like, of the stars, and now I'm sick and now I'm dead. We just had no idea. And when you come from that place and thinking about life, it's very easy to be fearful of it. And by understanding of it, you can get beyond that fear. Now, back in somewhere in the 1800s, some grape growers in France were just really tired. They were pissed off that people would just go in their vineyards and grab clusters of grapes and eat them. Disgusted enough to the point that they said, screw it, I'm going to spray this copper sulfate compound and make everything blue. I don't know why they had copper sulfate, but that was their idea. And so they started spraying copper sulfate so no one would eat their grapes. And then they found that somehow the copper lessened the disease that they were experiencing. And so was born the idea of spraying certain materials. And one of those materials is called Bordeaux spray. Bordeaux is a mixture of copper sulfate and hydrated lime. You know, I haven't done that for years and decades. I haven't done that. But this notion of some medicine to address a disease happening began with that moment. And the search has gone on ever since for what works. You know, we went to sulfur in the case of disease organisms. On the insect front, back around the turn of the previous century, they started using arsenical dyes. So there were spray materials called London purple and Paris green. It was a very colorful time. And then they got into lead arsenate, which we know has carried forward as lead-laden soils where fruit had been grown, can be a real issue now in the present time. Then we got into World War II, and so was begun the whole era of organophosphate poisons and EBDC systemic fungicides and a whole slew of things. And today we're into the neonicotinoids and more targeted fungicides, but it's still the same kind of thinking, all based on this idea of somehow we need to clean the slate, wipe out whatever the disease organism is, and in doing that, we forget all the other organisms that might be there, that might be the real true counter to the disease organism. So as we get into talking about a specific disease, there's a couple of things we learned from its life cycle. So I'll just quickly run through apple scab. Apple scab is a fungus that overwinters on the fallen leaves, and in our part of the world it's cold enough that it's not still up in the bud scales. It's totally down on the ground. As things warm, this may shift for you in Indiana before me in New Hampshire. So I won't get into the tree part of it. So down on the ground, in late fall or very, very early spring, it gets mature enough to do a reproductive stage, and it forms spore sacs. Those spore sacs have to mature, so they're not like instantly ready from as soon as the snow melts, but they have to mature, and when rains fall, it releases any mature spores by the tens of thousands that land on the surface of plants, and when it happens to be an apple, it then germinates and sends a hyphae to penetrate into the tissue, and that's the infection, which we see as a black spot. So scab is a black spot. And there is a period of time when those spore sacs release those spores that lasts about 4 weeks, that coincides with before bloom and about a week or so after bloom. And if during that time we can lessen primary infections, then during the summer there's not infections that now have a new round of spores being released called conidia that causes secondary scab. And secondary scab, things just get worse and worse, non-marketable. It's not just spots, but it's just like the whole surface of the fruit is lost and you're not even getting your juice potential. So there's a timing to when we want to lessen primary infection, and there's also an understanding of where did it overwinter and can I lessen, can I decrease the amount of inoculum that comes back at me the next year. So in talking about a specific disease, I have to understand where that launching pad is and how I might lessen the amount of inoculum. And I have to understand when the primary infection occurs so I don't have subsequent worries. I mean, I don't have to necessarily totally control it, but I don't want it to get out of hand. Now, I'm going to look at another one. Scab, apple scab is kind of simple. Another one is very ubiquitous, and that is the fact that stone fruits rot just like days. Sometimes it seems like hours before you were ready to pick it. But there's actually a much longer story in front of that fruit ripening moment. So brown rot, the fungal organism that causes that, overwinters in either mummified fruit still on the tree, mummified fruit that has fallen down to the ground, or in twig lesions. So mummified fruit still on the tree, what's a way you might address that? When you're pruning your stone fruit in spring, you pick the mummified fruit off and you put it in your pocket to send to your sister in Idaho or whatever. But you get it out of the orchard. On an herbicide strip, mummified fruit just lays there and does sporulate. In a more active living soil ecosystem, there's a chance a good portion of that will be broken up, will be decomposed. So I'm going to assume that that takes place. But the challenge is those twig lesions where the infection was joined to a fruit the previous year. It's not just the fruit that rots, but there's a fungal aspect that goes through the stem and overwinters in twig lesions. And those twig lesions are a problematic launching site because they're right next to where it blooms and where fruit grows next year. So in that case, there are spray methods to try to knock back what might come out of those twig lesions. The first round of spores infests the blossoms. So you may not notice these blossom clusters that get watery because it's here or there in the stone fruit. But that in turn becomes the site of a second round of spores, which are what get into the fruit through things like those oriental fruit moth stings or through a weak cuticle, because metabolism is depressed, it's sluggish, and so a weak cuticle has cracks in that waxy covering that rots can get through. This is again why I'm trying to maximize plant metabolism. I want robust fat synthesis. And that's where the rots seemingly just before the fruit's ready rot the fruit, and especially if it's rainy, rots are going to be all the more of a problem. So let's say as a home orchardist, you'd like to see less scab and get more decent looking fruit. We're not trying to totally eliminate all the spots. That's going to be kind of simple to achieve in the holistic spray schedule. Let's say you're commercially growing stone fruits. You got to deal with the twig lesions, You got to deal, oops, I always do that. You got to deal with the blossoms stage. Can you boost immune function there? And you got to deal with the fruit stage. Can you strengthen the cuticle? So you can start to see that that's a little more complicated. And I'll give simple methods that aren't necessarily as surefire. But again, it depends, are you doing this commercially? And what's the pressure on your site? And in a rainy year, you know, pressure is a lot more intense for all fungal diseases. It's just the nature of how it works. Cherry leaf spot, the same idea. And if we were to look at this life cycle, we'd see that those holes in the leaf, the infection is on the perimeter, on the circumference of that hole. And when those leaves fall, that's where the spores come back from next year to infest it. What's the game about? Decomposing as many leaves under the cherry tree so you have less of a launching site. So this is just the framework, the way to think about disease. This is apples where secondary scab took place. These actually don't look bad compared to how severe scab can be in a rainy summer. So stopping that first cycle is really important so that you don't see. So we start at pink. Enjoy this moment because everything goes downhill from here. And I don't totally mean it that way, but this is when things start to reveal themselves. So scab is something that even after that rainy spell and spores landed, we still don't see that infection for 10, 14, 16 days later. Again, it's all an invisible realm, but then it makes itself where you can see it. So there's a few factors that go into scab. So this is all great research done at land-grant universities. Various ones contributed. But what they were doing was let's really understand when infection takes place. And so these curves reflect the pace of spore maturity. And there's three factors involved. One is that younger tissue is more likely to get an infection than older tissue. So that just points to spring. And then later in early summer, shoot growth, where young tissue can be found. But once leaves get 2 weeks old or so, they're not really probably going to see scab. Another factor is that, here I am a tree again, here's my canopy in spring, but now I just have some bud points that are swelling and showing green tissue. Early spore release, there's hardly any target. Another 2 weeks of growth, and I have most of my leaves unveiled and I have shoots elongating. The target is much bigger. So there's going to be a time in spring where the odds go way up. And then it's the fact that these leaves in the previous year where the spore sacs are forming, well, over there they might mature really fast because they're in a dry place in the sun. Over here it's wet along the fence, and it might be 4 weeks later that those spores are ready. So it doesn't all happen at once. And I use this chart pretty much to gauge every rain event. And you don't have to get into it to that degree, but it's that orange section in the middle where all the odds come together. And that orange section basically represents what's known as tight to open cluster to pink on the apple bud before it actually opens up and becomes a blossom, to about a week to 10 days after the blossoms come off the tree. That's the period what's known as the primary infection window for the apple scab disease. So when we talk about cedar apple rust, that window is going to actually shift a little bit later. And that becomes relevant if you're losing way too many apples to cedar apple rust. So it's about who are you dealing with and what's the period where maybe a little extra steps are necessary to see your way clear. Now another thing about fungal diseases is the rain hitting the ground wets the leaves on the ground, which releases the spores. The spores land, but then the surface of the new growth has to stay wet long enough for that spore to send its hyphae out to access nutrient resources. So at 50 degrees, it requires 11 hours of wetting. So earlier I talked about tree spacing, and one of the functions of that is to help things dry out a little bit quicker. One of the primary ways we do that is through competent pruning. Again, Pandora's box has reared its head. We're going to keep it shut. But competent pruning means that, well, it's hard to keep it totally shut. It means that this bit of advice I heard long ago from a Vermont hill farmer went like this. If you've done a good job pruning a full-size tree, let's say 25, 30 feet tall, you should be able to pick up the family cow and throw her between the branches, between the scaffold layers of branches, so that sunlight and drying breezes are getting into the buds. You know, if you're growing apple trees on semi-dwarf rootstock, that's where the golden retriever comes in. And the real advantage of dwarf trees is cats. No, I've never thrown anything. You see this, but the idea is you're reducing the time the leaves are going to stay wet by virtue of winds and sunshine getting in there. And there will be some scenarios where the 11 hours never happen, and that means any spores released by that rain event shrivel up and die. This is why some years seem better than otherwise. This is why a really rainy year can be really intense. So in organic orcharding, the use of mineral fungicides is the primary way to do this. So to best understand mineral fungicides, and I'm doing this very briefly because we're not going here. Copper. So those twig lesions that I mentioned for brown rot, if you really had an issue with brown rot, it's probably advisable the year before, it's probably advisable that you do a copper spray when the tree is still dormant before tissue is showing, or just as tissue starts, because copper, it basically works like this. You're a happy disease organism and you're walking down the street whistling, and you walk in front of a 4-foot building, a 4-story building, and up on the roof someone pushes a blue piano off the roof and it just crushes you. Copper works like that. It just crushes life. That blue piano is a metaphor for copper. So it's a blue metallic coating that you're going to leave on the tree. It has a place. Similarly, if a bacterial disease called fire blight has really gotten a foothold in your orchard, you might start the season by throwing a blue piano out there. But mostly you don't want to do that because copper in excess also harms soil life, harms earthworms. You don't want to depend on it, but I don't want to take it out of our options if it's needed. Sulfur works by being on the surface of the leaf, and it dissolves into the moisture puddle that develops as a result of rain falling, and it makes that moisture puddle, the surface of the leaf, more acidic, which slows down the production of enzymes by the disease organism that the hyphae requires to punch its way into the leaf. So it essentially, it slows down the process, and by doing so, makes the amount of wetting time required longer, which means the odds of it drying out sooner are higher. Yeah, that's enough. And we won't even get into lime sulfur. We don't need to talk about that now. So mineral fungicides can have a place, even within a holistic program, and I'm going to talk about that, where you identify the one major wetting period, the mother of all wetting periods for that spring. And you might do that. Again, it depends on your history and the extent of what you're doing. But it also affects arboreal biology. You know, if you were sprayed with sulfur 20 times, you'd have a different life than you do not being sprayed with sulfur. It affects return bloom. It affects beneficial insects. When it affects return bloom, that means a lesser yield as a result. It can affect fruit finish, but many things can do that. And it can definitely affect your own happiness, which is worth considering here. So if you do use sulfur, you should understand that you want to buy a micronized sulfur product over a wettable sulfur product, just because the finer sulfur grains are going to last longer, up to 7 days on the tree. It's always been said that you need to have sulfur on before it rains. This is where you get into the 20 to 30 times, because if you go by the weather prediction, oh, it's going to rain Tuesday, got to spray sulfur. Oh, it's raining on Sunday, I got to go out Saturday and spray sulfur. In truth, with the micronose sulfur and a residual of 7 days, there is some carryover if you haven't had an inch or two of rain that totally washed it off. Again, in my book, The Apple Grower, I go into a lot of this nuance, and I'm not going to teach you how to use sulfur. I just want you to understand there's some concepts here. Then another part of the story is that if it's just a little rain, less than 1/10 of an inch, not so many spores are released. If it is below 50 degrees, not so many spores are released. This is how I keep track of net release, and I know when pressure is really high. Another aspect here is, and this is an important one, not only takes rain wetting the leaves on the orchard floor to release mature spores, it also takes actual daylight, ultraviolet light. So if it starts raining like midnight and it's dark, the spores sacs get wet, but they don't let go of the spores until morning, let's say 7 a.m. And so if it's the kind of rain that starts in the night, maybe it rains till 8 or 9 in the morning, then the sun comes out and a strong breeze starts blowing, that is just like perfect. That's like a perfect game in baseball, because all those spores are not going to have enough true wetting time after the point of release. And again, you'll see some springs and like no scab happens, because the sequence of events is all in your favor. But that's a rare spring. So there are these, this started at Cornell, but they're located throughout different places in the country. Weather stations that tie into a computer system. This is the NIWA system, where they track scab wetting events and tell you that here in, if there happens to be a weather station in Plainfield, this is where you are. This is a wetting event that should concern you. This is going to be minor. We just had a major release. There's not many mature spores ready to go. So this is something you would touch base with as a commercial grower. As we go into the next disease, I want to just say that I'm not opposed to an allopathic touch, that blue piano, sulfur for a real major wetting event, when it's needed to get things back closer to balance. And again, as a home orchardist, you're probably not going to go there. We're probably going to stick to the holistic program. But again, it's just like our own medicine. You know, just because there's antibiotics when we get a cough, we don't go take antibiotics and say, can I please sleep in the hospital where my clean slate body will now be exposed to every possible pathogen in the county. We don't do that, but we know that that's an option if there's something really severe going on, that's the appropriate direction to go. The same with our agriculture. Does anyone know what this is? I understand that you should know what this is. You have red cedar trees, juniper species, growing throughout the land here, and that tree shares a fungal disease with the apple tree, also with quince trees, also with pear trees, but they're different variations. This is cedar apple rust. So on the cedar tree, this is basically the spore sac that we don't see on those fallen leaves for apple scab. This is the spore sac. This is where the bolidiospores are going to come from that infect the apple tree. On the apple tree, what you're going to see is orange or yellowish spots. That tells you totally I'm dealing with cedar apple rust. So even if you haven't seen those gelatinous bombs on the red cedar tree, you're going to know yellow and orange spotting, cedar apple rust. It's not frog eye leaf spot. That was purple and tan spotting. So that's a big indicator. A little of this is not the end of the world, but if there's a lot of this spotting on the leaves, then you get early defoliation. That means less photosynthase. That means less nutrients stored next season, and the trees start to weaken, and they're more subject to issues. So one approach to rust is to plant varieties that are resistant to rush. And in a little bit, I'll be talking about scab immune cultivars that were developed at Purdue, Rutgers, and I think it's Illinois, or is it Indiana? I'm not sure. But if in the name you see a PRI in a row, that is Purdue, Rutgers, Illinois universities. And they're using genetics from a tree that's growing on the campus of Purdue that has resistance to scab. And a few of them also have resistance to rust. So there's Williams Pride, PRI. Liberty was developed at Cornell, but it's in the same category. Enterprise, there's that PRI. It has resistance to both of those diseases in the genetics. That apple that's in the picture is a Japanese apple called Akane. And Akane has a more deeper resistance to many disease organisms because it has a tie to another apple that offers this broader disease resistance mechanism. Anything in the russet family, like Roxbury russet, Asmeech kernel, doesn't have rust issues. Anything from the southern apple tradition, the limber twigs, doesn't have rust issues. So this is one way to approach it. And if you're content with the choices that you have, and there's some great choices there, then super. Let's not deal with that as one of the things on our list in the home orchard. On the other hand, there's all these wonderful varieties, and maybe you want to delve into some of them. So unlike apple scab, which is subject to the acidity of sulfur, sulfur does nothing for rust. So if you read that somewhere, don't drop it. That's not the approach to go. For some reason, cedar apple rust is inhibited by making the leaf puddle more alkaline. But this is complicated. So the use of potassium bicarbonate or baking soda, sodium bicarbonate, it isn't like you put it on before it rains. You need to put it on about 6 to 8 hours after the rain has started, before the leaves dry out. And somehow the cedar apple rust spore with its hyphae, at that point it's put the hyphae out, the alkaline shot dissipates it. This doesn't last that long, and that's why you have to wait. So 6 to 8 hours might look like it starts raining at 4 o'clock, and spores are released, and you're supposed to go out at midnight and spray your tree. So it's not easy to necessarily achieve. That's cedar apple rust actually taking out the fruit itself. And I'm going to talk about fermented plant extracts and how terpenoids induce a systemic response. This is just kind of a homeopathic slide. If I was in this part of the world, I'd be making a fermented plant extract of cedar needles from whence it came, because I think it will induce that systemic response. Now this slide is where the real answer to cedar apple rust gets unveiled. And not so much the words, this is just words grouping diseases in different categories, but it's the picture. And this is a picture of a cedar apple rust spore, and there you see the hyphae coming out of the spore, and it is plunging into an opening on the underside of the leaf, which is a stomata, which is the respiratory cell on the underside of the leaf of all plants, where oxygen and carbon dioxide are getting exchanged. And that open doorway means that cedar apple rust is totally evading the phytochemistry defenses of the plant. It doesn't have to punch through a cell. It's just saying, oh, here's an open door on the underside of the leaf. Underside of the leaf, an open door. There's that open door. That particular stomate, at this magnification, you can't see the biology around it. And when there is biology around it, and we're going to get into what I mean by competitive colonization, then it becomes a guarded open door. And it's a totally different ball game. So that sets us up to learn a little bit more about the holistic approach to fruit tree disease. We're going to change the paradigm. We're going to understand that the need for fungicides, for spray medicines, is predicated by there being nutritional and biological deficiencies. Nutritional, that's the immune function of the plant. Biological, that's the guardians at the doorway, not plus the soil food web activity going on down below. So I'm going to make a point about how to think anew about disease by giving two examples about us as humans, because we're really all derived from the same source. So when I talk about enhancing the tree's immune response, I'm here because I was willing to get on an airplane. And I got on an airplane as I think a relatively healthy organism, by which I mean I eat a diet of free-range eggs and whole grains and nutrient-dense produce. I get a solid 8 hours of sleep each night, mostly. I'm meeting the deadlines for my next book. I'm dealing with the stress in my life. I'm healthy because I'm openly and honestly dialoguing with my wife, Nancy, which isn't easy for men to do. I'm healthy because my teenage daughter, Gracie, is honoring and respecting everything I have to say as her father. I mean, I am like just floating. I'm just good. But when I get on that airplane, I am in a new ecosystem, breathing air being recirculated by 100, 200, whatever other humans, some of who are not so healthy. We're introducing those invisible germs into the air. And so my exposure is a lot higher. So what I do, this picture is of echinacea. Echinacea as an herbal remedy boosts our immune system. And so taking echinacea tincture before and after a flight, using elderberry syrup is a really great thing to quell viruses from taking hold. Chewing on raw garlic. Yes, I am the guy in the airport chewing on raw garlic. Because it's like a localized, it's not an antibiotic per se, but it's an antimicrobial, put right in there where the entrance is. Every spring, depending on the disease we're talking about, there's a period. Remember that scab curbs with the orange block? The orange block is the airplane. There's a time when our trees get on the airplane, and even when we give them all the natural advantages in the world, did my mic go out? I'm still good. I'm blocking it, that's what's happening. Even when I give them all those natural advantages, they don't have some direct genetic resistance. The pressure may be such, and especially if it's all the more rainier, that a little something more helps. Now the other part, creating this competitive microbial environment. I'm standing up here, and I think maybe all of you see one of me. Maybe there's someone who sees more than one of me, but we should check what's in your water bottle. But in truth, there isn't just one of me here. I'm standing up here. I'm a community of 100 trillion organisms. My eyeballs are slathered with Lost Nation bacteria. My skin is reeking with this stuff. My respiratory tract, my digestive tract has all these allies. And as a unit, as a community, we're able to keep that status of health. Take that away, and I'm in trouble. Now, I'm a fairly consistent environment. My temperature just hums along with the microbes that live on me, and I offer moisture that's fairly consistent. Out in the outside world, that changes. There's a number of factors that can deplete the community of organisms that live on the surface of a plant. And so to renew that is to keep me in that place where as a team, as a community, we prevent pathogenic disease from taking hold. So in the fungal realm, there's all kinds of, tell me what time it is, there's too much glare from me. A little after 2, okay. We'll take a break closer to 3. In the fungal realm, there's different corners of the fungal kingdom. So we've talked about the saprotrophic fungi that decompose organic matter. That's really, really important. That's where nutrients come from. We've talked about the mycorrhizal fungi. Tomorrow I'm going to talk more specifically about arboreal biology. There are fungi that live within the leaf and within the stem, running up the cambium of trees. There are all sorts of yeasts and bacteria that live on the surface of the plant. That's the community, part of the community of that plant. It's not just the organisms in the soil, but what's above. And then lastly, that last group, the ones that cause disease, the pathogens, the parasites. When we made a decision in our agriculture to address that last group by spraying Bordeaux spray, by spraying lots of sulfur, by spraying chemicals, we changed the ecosystem for everybody else as well. And so all the advantages that come from our boreal food web and the soil food web, fungicides, not only do they kill the diseases that land on the surface of the tree, they drip to the soil. They kill the mycorrhizae. They kill the saprotrophic fungi. And we just keep pushing ourselves into a place where now we need more medicines because we have more and more deficiencies on the biological and nutritional front. And it's just the framework of how we think. I mean, it's understandable, but it's time to break from that. So in working with plant immune function, there'll be some words that sounds like I'm kind of talking about the human immune system as well. There's an innate and an adaptive aspect to this. So the one leg is triggered by the actual presence of disease. So again, just like with the apple maggot fly and the blueberry maggot fly, it takes a little, it takes real environmental reality that's going to trigger what's called the systemic acquired resistance pathway. And it's a good thing. And we're certainly growing trees in environmental reality, and if we don't change the conditions with the fungicidal fog, then plants are going to produce certain phytochemicals in response. And this is known as the salicylic acid pathway. And it starts with an oxidative burst. If you've ever read anything about controlling a certain disease with the spray of hydrogen peroxide, we're just mimicking what's going on here. Then levels of salicylic acids build up. You might have read about taking something like willow water, or there's products you can buy high in salicylic acid. Again, it's about stimulating this response. This is what plants do naturally. And the end result are resistance metabolites known as phytoanticipants. Now, the takeaway here is it requires balanced mineral nutrition, we're back on mineralization, to achieve the wide range of phytochemical response that's possible through this pathway. One of the ways I convey this to people is in the barn, our post and beam barn where I sell apples. I have these green men on the wall. And some days, the green men feel like talking. Some days I take down what they want to say because I don't want to talk to anyone. But on the days they want to talk, you'll see things like, what do spots have to do with healthy apples? Which, of course, I'm asked. And then I quickly explain about phytochemistry. I'm talking like 30 seconds. Phytochemistry results because the plants experience, they respond to some disease. And I'll bring up, you know the saying, an apple a day will keep the doctor away. And maybe that was true in the mid-1800s when that was coined. That was trees, plants growing in a living, healthy soil ecosystem, experiencing environmental reality. But when plants are way over-medicated and the microbe community is not in place, you have a whole lot less of those phytoanticipants, which we evolved with, which help us with degenerative disease. We were talking about that earlier. There are limits to the systemic acquired resistance alone. This is why there's a picture of goats. If I ever put up a picture of goats, it means I'm talking about serious problems. Goats and trees do not mix. And one of those limits is just the fact that prolonged periods of rain, that means a reduction of photosynthesis, radically limits how far this can go. And it's in those rainy periods that we need to do a little bit more. So the other leg of plant immune function is inducing systemic resistance. And here, the takeaway is that, remember, you're going to be able to see these slides. I'm going fast. The takeaway is that multiple mechanisms work better than a singular mechanism. And the business about effectiveness lasting on the order of 10 days is going to tie into the frequency of when we might make such applications. So now I'm talking about the inducing elicitors. This can be anything from other microbes to certain herbal remedies, those terpenes and phenols that I can extract into a liquid form to spray on the surface of the tree, to nutrition like dehydrated ocean water, the ionic minerals, to liquid or seaweed extract, to liquid fish. All these things, microbes, compost tea, induce this response. Now, I'm not going to spray everything under the sun, but I want to focus on what's maybe the right combination. And in that context, I also want to be sure to keep the biology, the arboreal food web, at a colonization level of 70% or more, because that's where the magic happens in terms of enough guardians at the gateway to prevent disease. Now, microbes outside in the environment are subject to a lot of different forces. And so we can't do much about extreme heat or deep cold, acid rain, or ultraviolet radiation. We do make some choices. If we spray fungicides, of course we're going to destroy the arboreal food web. If we use nitrate fertilization, the plant's using reserve energy to actually get to the ammonium stage so it doesn't have as robust metabolism, and that impacts arboreal biology as well. And then finally, there's the overlooked fact that food resources can run out. So my microbes, I don't know what all they're eating. I know they get some beer, but other than that, I'm not sure what they're thriving on. But out on the surface of the plant, food resources can run out. So we, in understanding that, can replenish those food resources. Now, Elaine Ingham has done a lot to teach people about the soil food web and compost tea. And she talks about, we know so little about these realms. And do we need to know the names of every beneficial fungi and every beneficial bacteria to work with it? No. We just need to know that in diversity, it all comes together. So a really good way of me explaining that for you comes under the banner of what I call probiotics for trees. And in this picture, I'm using a probiotic effective microbe product, and we're going to talk about that. But let's pick up this trail by going back approximately 120 years ago. At that time, in the eastern forest, 1 out of 4 trees was an American chestnut. And for whatever reason, some potted Chinese chestnuts were brought into this country and planted in Central Park in New York City. And in that Chinese chestnut biome was a fungal disease that's called what's now known as chestnut blight. And this fungal disease, and you really got to understand how amazing the chestnut tree was. I don't know if you can make that little human where the 2 arrows are, but these were big trees. These were like the redwoods of the East. And if I could go back in time, this would be one of the reasons I'd want to go back in time to be that man standing there. Within like 30 years, 80% of these trees were killed by the chestnut blight organism. I should change that word, killed. Were killed above ground by the chestnut blight organism. But all that time, the chestnut tree was telling us, there's a lesson here. Pay attention. Wake up. There's something you can do to help us. That lesson lied in the fact that it was killed to the ground, and then stump sprouts, new growth would arise from the root system. Typically it got to live for like 15 to 25 years, just begins to have nuts again, and then a new round of blight would come through and kill that, and then it would do another round of stump sprouts. What's happening is the foreign organism that's killing the cambium of the tree above ground at the soil line meets the North American soil food web and is instantly out-competed. So for the last 50 or so years, the American Chestnut Foundation, people have been working to back-cross Chinese chestnut genetics into the American chestnut, and then get a new round of nuts, and then cross with American chestnut again, so you can get back more to the pure American chestnut genetics. And in order to get those nuts, the people growing these trees have learned that the answer to chestnut blight, it shows up first as a lesion, so it's not the whole tree just dies like that, it's a spot where the bark flakes off. The answer was bend down and pick up some earth and rub it into the lesion so that the chestnut blight organism was meeting the North American soil food web. So this guy is up in the tree, keeping a young tree alive long enough so it can produce a viable nut so we can go for the next generation cross. This is a picture of the underside of a leaf. And you see the leaf vein, those little spikes are leaf hairs. But you can actually see individual cells on the surface of that leaf. You can actually, because it's the underside of the leaf, see the stomates. I'm going to now increase the magnification yet again and look at what the surface of one cell alone looks like with microbe colonization. What looks like pills are various innocuous bacteria, things like Bacillus subtilis. What looks like floating blobs with little white webs around them are a unicellular fungi, the yeast. And this is what makes up the bulk of 70% colonization. This is what runs out of food. This is what is subject to extreme weather conditions and gets depleted. So renewing it can take the form of certain microbe cultures, what I'm calling probiotics for trees. And this particular culture that I'm going to talk about comes out of the natural farming movement in Japan. And so it's a mixture of three groups of organisms. What makes it very effective economically is that you can activate it. You can take a gallon of mother culture and make 22 gallons of activated culture. And that simply involves feeding it blackstrap molasses and certain temperature steps. So it's a lot like brewing beer, but now you're filling the volume of water with microbes. Those three groups of organisms, they're all under the banner of what would be called facultative organisms. And by that I mean that they're able to live and reproduce in an anaerobic environment as well as an aerobic environment. That's part of why these organisms were selected. So that's an entirely different concept than what happens with compost tea, which is all about aerated organisms. The photosynthetic bacteria, we wanted to be crude about it, pond scum, are the ones that can take light and produce food, can take that energy just like plants can do and create carbon sugars. So they actually contribute to the ongoing need for food resources on the surface of the leaf. The lactic acid bacteria you're all familiar with when you make sauerkraut or you eat a pickle. And the fact that that lactic fermentation creates a suitable environment for lactic acid bacteria to stabilize, well, those lactic acid bacteria protect their niche. This is why the sauerkraut doesn't go bad. This is why the pickle is still good and tasty, protecting their niche. Well, that's a pretty good skill set to put on the surface of a leaf where pathogens are landing. And then finally, there are the yeasts, which basically I think of them as the crowd. They're going to consume some of the resources needed by the pathogen, and et cetera. But all that together, when it becomes 70% colonization, is a really important part of tying in with natural disease resistance mechanisms. So activating EM, again, this makes it economical. So 5 gallons of mother culture that I get to use on 3 acres of orchard and on our gardens as well costs me about $250 plus shipping. That's a lot of money for what it is. That's the way it is. But when I add 3/4 of a cup of blackstrap molasses to 3/4 of a cup of mother culture in every gallon of water, I can get 22 times as much volume. And now that cost becomes more like $5, $6 a gallon for the microbes. So if you're a home orchardist and you don't want to bother with this, you just use the mother culture, but you need much less than I do. And so that's one approach to going about this. And it's about, I haven't told you about my website, groworganicapples.com. There's a discussion forum on there, and there's some great threads about the nuance of brewing microbes in barrels and using a heat belt. But it's basically keeping the temperature of the brew at about 100 degrees for the first 3 days, at which point the lactic acid bacteria wake up, and then dropping the temperature to more like 80, where the photosynthetic bacteria wake up, the pH drops, it's ready to use. It keeps on the order of, the manufacturer will tell you use it within 30, 40 days, but it really keeps on the order of 60 plus days. And that ties perfectly well into the spray schedule. And we're going to get into that, and you'll see how things weave together. So what happens when you have lots of organisms on the surface of the leaf? One of three things. In the soil, we know that microbe eats microbe. That's one of the possibilities. Another is that the microbes who are there in that niche before the pathogen arrives use some of the food resources. There isn't what's necessary for that fungal hyphae of the disease to get what it needs to produce the enzymes to punch its way in. And finally, the notion of protecting a niche means the microbes that are there produce antimicrobial compounds. They produce antibiotics. You know, when we talk about fire blight, I'll talk about synthetic antibiotics that are used and how that's proving problematic. How much better to have the source there, the organisms themselves that produce such antimicrobial compounds. You can do this with compost tea. It isn't like that's the only organisms that are going to work here. Many things work in this respect. So people working with compost tea, I've heard for years, I tried it, it's not really working. They were forgetting something. They were forgetting the fact that food resources run out. Now we're starting to tie together what's going to lead to what I call the holistic core recipe. So Einstein said, no problem can be solved from the same level of consciousness that created it. We've spent some time now changing the paradigm. You're starting to hear about, okay, I need to boost the immune function of my plants when they get on the airplane. I need to have that competitive colonization in place so that no one gets in through the open doorway. This is the way we're going to address diseases, noting that each disease has its own particular characteristics. So it's not going to be all one plan works everywhere. So this brings me to what I call my NRA moment, the National Rifle Association. It's not the sprayer that kills, it's what you put in the sprayer. So the sprayer is just a tool. And the reason I say this way is because I hear from quite a few people that I'd love to grow fruit, but I don't want to spray. And they're referring to, I don't want to spray organophosphates. I don't want to spray that copper. I don't want to spray fungicides. I don't want to spray herbicides. I get that, but the sprayer is innocent. It's just a tool, and it depends what we put in there. So let's go back to our root chart and add some fungal dynamics to it. So this is part of your handout. In the spring, I'm very interested in two aspects. One, helping to further decompose anything that didn't get decomposed that overwintered, the fallen leaves. And I'm also interested in stimulating the feeder root response, particularly the mycorrhizal fungal aspect. And so I actually, in my first 1 or 2 sprays of spring, don't only spray the tree, but I spray the ground under the tree. I'll get into more specific about that. That's represented by the brown portion of the curve. The red portion of the curve represents two things. One, soil food web organisms arising and coming up onto the surface of plants. And that happens, just think rain splatter, birds flying, microbes get up there on the new tissue. It also represents the timing of when pathogens get their foothold and cause disease. So thinking about two things. We need that arboreal biology, but it's also when disease is we're preventing the first stage of disease. The green portion of the curve represents what's going on with the mycorrhizal pulsing. And so you can see that spring feeder root flush, and then as the curve proceeds into the fall, it comes back down really strong. This is when nutrients are being taken up for different purposes. And so some of the things I'm doing are making sure if I'm shallow cultivating, I do that at the height of summer, not in the spring, not in the late August, September, because that's when the feeder root flush is taking place. And then finally we have harvest takes place and leaves are dropping, and I want to make sure I can decompose as much as I can. So I'm tying to what the root system is doing, but I'm also kind of aware of what's going on fungally. So my spray, my holistic core recipe, you know, typically in a fungicide or an insecticide product, you list the active ingredients. The active ingredients I'm going to work with are trace minerals, fatty acids, and microbe diversity. All pretty good stuff. And this core recipe is going to consist of different seed oils for the fats, fish hydrolysate, and I'm going to explain what that term means, seaweed of one form or another, and some version of microbial inoculant. So the first category, the seed oils, the primary one that I like to use is pure neem oil. So neem oil is pressed from the seed of the Azadirachta tree, which grows in India and Southeast Asia and North Africa and southern Florida and southern California. It might be 10 years till I can grow neem trees in New Hampshire, because things are shifting. That's, I hope, a joke. But neem contains three things. It has a high level of terpenoids, which is one of those resistance metabolite words, and terpenoids stimulate the same in the tree that gets sprayed. It contains a host of different fatty acids that feed the biology, but are also absorbed by the plant. And the thing that's unique to neem is it contains what are called azadirachtin, which inhibit the molting cycle of certain insects. So I'm going to examine that in more detail when we get to the insect portion. But that's only found in neem. I happen to get my neem from a woman in Minnesota who has that business, neemresource.com. And I'm talking here about pure, 100% unadulterated, unprocessed neem, because I want those fatty acids. So you'll see in organic catalogs or even in the local Agway store neem products, but they're neem extracts. They don't have all the fats that feed the microbes. We're doing a different thing than just emphasizing the azadirachtin. I'm not interested in those spray products. They cost a lot more. I want the real thing, just like you want real 100% olive oil. You don't want it adulterated with other oils. You want the real thing. Working with unadulterated neem, there's a few requirements, otherwise it'll be complicated and you'll be mad at me. I can live with that, but I don't want you to be mad at me. Below 60 degrees, neem is like butter. So you have to emulsify it. You have to liquefy it. By liquefying it, I mean just the day before, realize, oh, I better get out my neem from the cold basement so that it can warm up enough to go to a liquid state. That in turn, that neem needs to be emulsified. And by this I mean, if you put oil and water, it doesn't mix. So you need to use some soap to emulsify the neem fats so they will disperse throughout the spray volume of whether that's a backpack sprayer or your tractor sprayer. And it doesn't take much soap. Things like Clover, 7th generation, those biodegradable soaps work really well. If you use Dr. Bonner's, it's a slightly weaker soap, so you have to up the amounts from the rate I'm talking about. But you can tell when you take the pure oil and you put in the soap emulsifier, you'll see that it's distributed fairly well. And when you in turn pour that into water, you won't see big, huge fat globules. If you see big, huge fat globules, you either need a little more soap or a stronger soap. The warm water part I've done, but I've learned that with my water, it pretty much mixes without me going through that step. But what's important is you may have hard water, by which I mean high levels of calcium, and that in turn undoes the action of the soap. So you have to make your water a little more acidic, which you can do with like lemon juice or citric acid. And that's just a matter of learning it. So as I get into this and the nuance, it sounds, he's doing all this stuff. What kind of a life does he have? Well, I have no life. What's it to you? I'm saying, no. It falls in place. Trust me. If you get into this and you're understanding what you're doing and why it's working, you'll follow the steps. So another aspect is that, let's say you have, I don't know, I'll guess 12, 16 trees, and maybe a part of something you're growing in your garden that you want to spray with neem. And let's say that to cover what you have requires a pint of pure neem oil each time you spray. And let's say that you're going to do this 7 or 8 times throughout the season at prescribed points. That means that you need 8 pints for the season, so you buy a gallon. The first time you liquefy the gallon, you should have 8 empty pints there to pour it in. And that way, when you put the pints back into a cooler place to store them, you're only getting one out at a time, rather than taking the whole volume and liquefying it, storing it. Because that going back and forth from liquefied to more like a butter state starts to break down constituents. So that's how you're going to get effective use of neem. And if the neem's down in that cooler place below 60 for 2-3 years, it's still fine to use. So maybe you buy 4 gallons because you want to get 3 years worth, but you just have to treat it right. Another important part is to clean your backpack sprayer or your tractor sprayer so that there's not fats lining the tubes and in the pump. And that just means taking a degreaser soap like Citrusol or that Simply Green degreaser product that's pretty commonly available, and flushing a half gallon or a few gallons through your tractor sprayer just so you clean things out. And that's a good practice in general. The whole thing with the EPA registration number, if you're certified organic, you're probably required to say, I'm spraying this product and it has the EPA number. That means you're going to pay for NIM Biosys, which costs about 30 to 40% more than the neem I'm getting. The pure neem oil I'm getting is actually used by people who make hand lotions and different herbal cream products. Neem has been used for thousands of years in Ayurvedic culture, both in agriculture and for healing purpose. In Canada, they're not allowed to use neem because no one's registered it the way it has been registered here. But you can buy it to make lotion, but you can't spray it on a plant where you're growing food, because the economics of registering something that will only be used by a few people just isn't there. It's not that it's dangerous. Another component that I add here is I now take 1/3 of the seed oil recommended rate to get 0.5% concentration, and I use Karanja. And I'm going to explain how that ties into bloom time. I don't apply neem during the bloom period of the fruit tree because I don't want to inhibit the molting cycle of the pollinators. I don't think that happens all that much, but I want to be sensible and wise about it. I'm just going to run through the nuance of all these components, and then we'll take a break. So the fish portion. When you process fish, when you cold process fish, the fish oils, the enzymes come through that feed the biology. When the fish oils are removed for fish oil products and the resulting brew is heated to preserve it, heating means pasteurized, that is what you would call fish emulsion. You want the cold processed fish. That process is called hydrolysis, and that's where the word fish hydrolysite comes from. And with fish products, because it is considered a fertilizer, it has an NPK number on the label. So N for nitrogen, P for phosphorus, K for potassium. And when the first number, which is nitrogen, is 2 or 3, you are truly getting a fish hydrolysate. When that number is 4 or 5, or spiked to be even higher with synthetic nitrogen, you're getting a fish emulsion and possibly buying a product from a company that is not that reputable, because it's very easy to call any of this, quote, liquid fish. So just knowing about the number part. So names like Organic Gem, Neptune's Harvest, Dram, which is out of Michigan, Schaefer's Fishery, which is out of Illinois. In the case of Schaefer's and Dram, the primary fish that they're using is Asian carp, which we want to keep out of the Great Lakes because it'll destroy the Great Lake ecology. So you may not be into this mass processing of fish, but it's often a fish that's caught up in some other aspect or protecting the environment. So for me, it's an important resource. This is something where, back to economy of scale. Fish is going to last 2 years, and I will order a pallet, and on a pallet, the shipping freight costs are the same, whether you put 1 barrel on that pallet or 4 barrels. And so I buy 2 years worth at a time, and that's costing me like $4 to $5 a gallon. If you buy a gallon through the mail, you're probably going to pay about $30 plus shipping. So you can see that getting a little bit more expensive. How do you work with that? So it's really neat to form neighborhood co-ops. Maybe you can share 5 gallons, or maybe there's a farmer who can order the barrel and will sell off some. That's something everyone can work out. The seaweed piece. Seaweed can either be a dry extract or a cold processed liquid kelp. Now, for most of the virtues of seaweed, it doesn't matter. So I mostly use the dry extract because it's cheaper to mail that than it is a liquid product. The one difference is that liquid kelp retains the polysaccharide content. So this is complex sugars that are in the kelp plant. And the value of liquid kelp is in spring during blossom time. So there'll be nights where not just a frost, but the weather people are talking about a freeze, a light freeze. At 28 degrees, 10% of all open blossoms will be lost to cold injury. Gets 3 degrees colder at 28, at 25 degrees, 90% of the open blossoms will be lost to cold injury. And if on the day of a predicted freeze like that, you go out midday and spray liquid kelp, maybe you spray other things, but definitely it's the liquid kelp, it acts like a plant antifreeze. It ups the sugar content of the sap in the blossom, and that in turn offers 2 to 4 degrees of cold protection, which is enough to go back up to that 28 degree level where you're losing a whole lot less blossoms. And that effect is going to last for 2 or 3 days. So if it's cold for a short spell, you don't have to necessarily be out there every day. Many years that has no value, but in the years when it really matters, knowing about that is important in terms of, especially if you're making a living at this. So the other aspects of seaweed is, in one sense, I think of it as a megavitamin. It has all this different trace mineral aspects, but particularly it's the cytokinin component that has flavonoids, which triggers a different leg of the immune function of the plant, and it also has the better effectiveness against bacterial disease. So I'm going to weave that back in later. The biological piece, the affected microbes can be purchased from either Terraganics in Texas, and these are companies that supply through different distributors, but you can order direct, or SCD Probiotics out of St. Louis. These are 2 that I know are reputable products. So the Terraganics product is called EM1. There's other ways to do this. I've mentioned compost tea. If you're a follower of Korean natural farming, there's a technique of utilizing rice placed out on the forest floor to get lactic acid bacteria. And I don't care how you do it, but you need to have the microbe component. You need to understand that that's a really key piece of this holistic approach. So the holistic core recipe, taken all together, is about stimulating green immune function and about reinforcing the biology, canopy colonization. So I'm going to introduce, nope, we're going to do the 5-minute break. Let's do the 5-minute break, stretch our legs, get a cup of tea,